Tell me, are the voice and screen clear? Tell me, are the voice and screen clear? All okay? Yes. So what we were discussing is something like this. If velocity is less than r omega, friction will try to increase the velocity and decrease the omega. Velocity less आहे, velocity ला increase केलं जाईल, omega ला decrease केलं जाईल, and ultimately this equality will be achieved. If velocity is more, then velocity will be decreased, omega will be increased, and again v will be made equal to r omega. So here velocity is more, so friction will try to oppose the velocity. Also friction can be zero, can be non-zero. Friction हे zero पण असू शकेल रोलिंग मध्ये, non-zero पण असू शकेल. So basically you cannot say that friction cannot be zero असं तुम्ही म्हणू शकत नाही. It can be zero, it cannot be, sorry, it can be zero and it can be non-zero also. This option is also removed. या दोन्हीतला चूज करता आला असता पण स्पेशल सिच्युएशन द्यायला पाहिजे. सो फॉर टाइम बिइंग वी हॅव टू गो विथ द ऑप्शन नंबर 4. मला सांगा लॉजिक क्लिअर झालं का? वाय आय एम गोइंग विथ ऑप्शन नंबर 4. जरा चेक करा, समजतंय का? त्यांचं पण सोल्युशन बघूया. क्वेश्चन 25 कारण थोडासा ट्रिकी आहे. येस, क्वेश्चन 25 ऑप्शन नंबर 4 इट इज. ओके, त्यांना हाच थॉट एक्सपेक्टेड आहे. ऍक्च्युअली ऑप्शन 1 किंवा 2 यायला पाहिजे, पण सिच्युएशन त्यांनी स्पेसिफाय करायला द्या. सिच्युएशन त्यांनी स्पेसिफाय करायला पाहिजे. फाईन सर, होप दिस क्वेश्चन इज क्लिअर टू ऑल ऑफ यू. फाईन. सो I think only the previous year questions are remaining now. Let's see how many previous year questions are there. There are around 30 previous year questions. Yes, we can go with them, all the 5 numbered questions. So 5-6 questions we can solve in this meeting. Okay, so let's move on with the move on to the previous year questions. Okay, all 5, 10, 15, 20 numbered questions we will be solving. Okay, so exercise number 4. Exercise number 4 or the previous year questions. Let's solve. Question number 5. Let us see what is given in the question number 5. Okay, here it is. Let us read it. A solid cylinder of mass 3 kg. So what is given? Solid cylinder, mass 3 kg. पटकन डेटा एक्सट्रॅक्ट केला, लिहिला. Is rolling on the horizontal surface with the velocity 4 meter per second. So we have one rolling cylinder. Actually this is cylinder, not a disc or ring. It is cylinder, but I will not be drawing that entire cylinder. If you want, you can draw it something like this, no issues. This is the horizontal ground. On this horizontal ground, this is our cylinder which is rolling on this cylinder, which is rolling on the surface like this. Okay, what is the data given? Mass of the cylinder is equal to 3 kg and rolling with the velocity of center of mass, जी काय velocity of center of mass है, that v is given as 4 meter per second. 4 meter per second. Fine sir. Next, it collides with the horizontal spring of force constant 200 Newton per meter. Okay, the maximum compression produced in the spring will be. Okay sir, fine. So try to understand. This collides with the spring. Okay, so let me draw it again in 2-dimensional situation. This is some object having some kinetic, translational kinetic energy as well as rotational kinetic energy. Let's say this object v and omega, let's say this object collides with the spring and compresses the spring. After compression, let's say the spring compressed by the distance equal to x. Spring काय झाली? x एवढ्या distance न compress झाली. When this object will reach here, when this object will hit here and it will compress the spring, and at this position there will be the maximum possible compression and again spring will again elongate. पहिल्यांदा compress झाली, इथपर्यंत मॅक्सिमम कॉम्प्रेशन झालं. आता परत स्प्रिंग ओरिजिनलला यायचा प्रयत्न करेल, पण इथं जाऊन तो थांबेल. सिलेंडर हियर द सिलेंडर विल स्टॉप, हियर द सिलेंडर विल स्टॉप. दे आर आस्किंग मॅक्सिमम कॉम्प्रेशन प्रोड्यूस्ड इन द स्प्रिंग. They are asking maximum compression produced in the spring. Okay sir, for that what you have to do, simply energyचा लॉस तर झालेला नाहीये, एनर्जीचा लॉस तर झालेला नाहीये, but total energy of the system initially is equal to total energy of the system finally. So here you have to write conservation of energy. Okay, we are asked compression in the spring, so x is equal to question mark, maximum compression in the spring equal to question mark. Okay, so total energy of the system initially is equal to total energy of the system finally. Okay sir, now initially in the system we have two things, this and this, so cylinder and the spring. Now initially the spring was not in the stretch position, it was in its natural position. Natural position मध्ये जर स्प्रिंग असेल तर त्याची पोटेन्शियल एनर्जी झिरो, कॉम्प्रेशन नाही, इलॉंगेशन नाही, पोटेन्शियल एनर्जी झिरो. सो स्प्रिंगची एनर्जी तर झिरो असेल. सो टीई हियर वी हॅव टू राईट टीई ऑफ द सिलेंडर प्लस, आता स्प्रिंगला फक्त पीई असते, स्प्रिंगला वेगळं काही नसतं. ऑब्जेक्ट स्प्रिंगला जर ऑब्जेक्ट अटॅच केला तर ऑब्जेक्टला कायनेटिक एनर्जी असेल, पण स्प्रिंग मध्ये मात्र पोटेन्शियल एनर्जी असते. स्प्रिंगला जेव्हा ऑब्जेक्ट अटॅच केला असतो तेव्हा ऑब्जेक्ट कडे कायनेटिक एनर्जी असते आणि स्प्रिंग कडे पोटेन्शियल एनर्जी असते. सो here right now there is no object attached to the spring, so only spring will be having some potential energy, but right now spring is not compressed, not elongated. Potential energy चा फॉर्म्युला काय असतो, 1/2 kx square, 1/2 kx square. Right now x, that is elongation or compression, is 0, so initially तर 0 होतो. So spring ची potential energy of the spring, this you have to write initially is equal to finally. So total energy of the cylinder plus potential energy of the spring finally. So initial energies of the components of the system is equal to final energies of the component of the system. Now as discussed, initially potential energy in the string is going to be 0. Fine sir, let us write here 0. Now total energy of the cylinder is what? Sir, total energy of the cylinder is, our cylinder is performing rolling motion, and rolling motion means translational as well as rotational. So total kinetic energy will be what? 1/2 mv square into bracket 1 plus k square upon r square. Okay, this formula just we have seen in the previous question. थोड्या वेळापूर्वी जो क्वेश्चन सॉल्व्ह केला त्याच्यामध्ये टोटल कायनेटिक एनर्जीचा फॉर्म्युला काय असतो ऑब्जेक्टच्या, rolling kinetic energy is 1/2 mv square into bracket 1 plus k square upon r square. Fine sir. Now sir, here finally the cylinder is at rest, maximum compression झाले, cylinder थांबलाय, आता परत येणार आहे, so here the cylinder is at rest. So if it is at rest, its velocity will be 0. If its velocity is 0, this term is going to be 0, cylinder at rest. But spring is in compressed position, so spring ची potential energy किती असेल बाळ, 1/2 kx square, आणि हाच x आपल्याला विचारलाय. Okay, now sir, this k and this k we may get confused. आता हा spring constant आहे, so let us write it as ks. हा spring constant आहे, so let us write it as ks, and this k is radius of gyration. Now what is the k square upon r square formula for cylinder? See, cylinder means ultimately disk over disk over disk over disk. These are n number of disks. So what is the formula for moment of inertia of the disk about this axis passing through center and perpendicular to plane? It is 1/2 mr square. Okay, you may draw the disk like this and axis like this, or you may draw the disk like this and the axis like this. Ultimately the formula is 1/2 mr square. Okay, and what is k square upon r square? It is coefficient of mr square. So k square upon r square is coefficient of mr square. 1/2 mr square. 1/2 is the coefficient of mr square. So sir, here 1/2 mv square, 1 plus 1/2 plus 0, no need to write, plus 0, no need to write, 1/2 spring constant into x square. Sir, we need to find out x, and we are given the value of velocity. Initial velocity we are given, mass we are given, x we are required to find out. Okay, but sir, spring constant of the spring is not given. It is given. Okay, so it is very important to extract entire data. It collides with the horizontal spring of spring constant of 200 Newton per meter. Okay, so we are given the spring constant. So let us write here the spring constant. Ks. What is that? It is 200 Newton per meter. It is 200 Newton per meter. Okay, fine. So now everything is given. Let us do the tick marking. Ks given, mass given, velocity given. So now this question in the physics convert into one equation, one unknown. In this entire equation only one unknown x is there. So sir, this one half gets cancelled. 1 plus 1 half is 3/2. 3/2 mv square. Mass is given as 3, velocity is given as 4, and this spring constant is given as 200 into this x square into this x square. Okay, try to calculate the answer along with me. सगळे calculation करा माझ्या बरोबर, सवय लागू दे calculation ची. This will become 16. 16 upon 2 will be 8. 3 into 3 is 9. 9 into 8 is 72. 9 into 8 is 72. Okay, so 72 divided by 200 असं काहीतरी व्हायला लागले. 72 divided by 200 is equal to x square. Fine. Now 72 upon 2 is 36 upon 100 is equal to x square. So sir, x square is equal to 36 by 100 means x is equal to 6 upon 10, taking square root on both the sides. So what is the answer? 0.6. Answer is 0.6. Is this question clear to all of you? Conservation of energy initially equal to finally. Initially system मध्ये कोण कोण होतं? Cylinder and spring. Finally system मध्ये कोण कोण आहे बाळ? Cylinder and spring. Cylinder ची total energy 1/2 mv square into bracket 1 plus k square upon r square. Spring ची energy, spring कडे काय असतं? Potential energy. How to write? 1/2 kx square. Initially spring was not extended, so initial spring ची energy 0. Finally spring ची energy 1/2 kx square, and x is the compression or elongation in the spring which was asked. Okay, reply me in the chat box. Is this method clear to all of you? Conservation of energy, collision of cylinder with the spring, collision of ring with the spring, collision of mass with the spring, same logic. Conservation of energy. Is this clear to all of you? Reply me in the chat box. 0.6 meter as answer आले. Everything was in SI unit. Just reply me clear and written. That won't take much time. Everyone is expected to reply. Waiting for your replies. Shall we move on to the next question? समजा लागलेत का बघा questions? Good. Fine. So now let us move on to the next question. Okay, that is question number 10. Question number 10. These are the previous year questions. Okay, we will be tackling these questions now. Now question number 10 is something assertion and reason question. So we will skip that question. Okay, and better we will solve question number 9. So assertion reason questions yet nahi balanno, so just forget about that. Question number 9 for compensation we will solve. Okay, the ratio of the accelerations for a solid sphere of mass m radius r rolling down an incline of angle theta, solid sphere rolling on the inclined plane of inclination theta without slipping and slipping down the inclined plane without rolling is. Now this is somewhat confusing construction of the word. Now let us read it carefully. The ratio of, ratio is asked, ratio is asked, ratio of acceleration for the solid sphere of mass m radius r rolling down an inclined plane of angle theta without slipping. म्हणजे rolling without slipping चा acceleration, acceleration of rolling, try to understand, without sleeping and sleeping down the incline without rolling, sleeping without rolling. Okay, sleeping without rolling, but fine. So angle theta, we have sphere, sphere will roll on this plane, inclined plane, and rotational motion will be about the diameter, about this axis which is coming out of the plane. Fine sir. Now rolling without slipping, rolling without slipping चा acceleration शिकवलं होतं, acceleration down the incline. Rolling without slipping चा acceleration शिकवलं होतं. Rolling म्हणजे गोल पण फिरायला लागलाय पण घासत नाहीये. ओके, न घासता गोल फिरत व्यवस्थित खाली येते. Rolling without sleeping, फॉर्म्युला लक्षात ठेवा बाळांनो, दिस यू ऑलरेडी नो ऑल्सो. इट इज g sin theta upon 1 plus k square upon r square. इट इज g sin theta upon 1 plus k square upon r square. मी तुम्हाला हे शिकवलं होतं बघा, वेलॉसिटी ऍट द बॉटम, एक्सेलरेशन अलॉंग द इन्क्लाइन, तेच आहे. एक्सेलरेशन अलॉंग द इन्क्लाइन म्हणजे रोलिंग विदाउट स्लिपिंग वाला एक्सेलरेशन. वेलॉसिटी ऍट द बॉटम, एक्सेलरेशन अलॉंग द इन्क्लाइन अँड टाइम रिक्वायर्ड टू रीच द बॉटम. तिन्ही फॉर्म्युले लिहितो. वेलॉसिटी ऍट द बॉटम, okay, when there is rolling without slipping, of course rolling without slipping, velocity at the bottom under root 2gh divided by 1 plus k square upon r square, under root 2gh divided by 1 plus k square upon r square. This is velocity at the bottom. Check whether I am right or wrong. Then time required to reach the bottom, it is 1 upon sin theta under root 2h upon g. And here this factor 1 upon k square upon r square is in denominator. Here also it is in the denominator, but in the formula of time it is in the numerator, but it is in the square root also. These are the three formulae: velocity at the bottom, time required to reach the bottom, and acceleration along the incline, म्हणजेच acceleration without slipping. Velocity at the bottom when the motion is rolling without slipping. समजलं? Now when there is slipping, म्हणजे जेव्हा तुम्ही घासत खाली येताय, when there is slipping, at that time, see, we are not given friction. Okay, we are not given friction. So when there is no friction, object will simply slide down. Okay, simply slide down, and that sliding acceleration will be equal to what? When there is simply sliding, this g will be resolved into two components. If this angle is theta, this angle will be theta. So this will be g cos theta, and this will be g sin theta. And there is no rolling motion. If there is no rolling motion, only sliding motion, means acceleration along the incline will be simply g sin theta. So acceleration of slipping without rolling, rolling नाही आहे, फक्त घासत जर खाली येणार असाल तर g sin theta ने खाली याल. So acceleration when slipping without rolling, no rolling motion, without rolling, दिस इज प्युअर रोलिंग, म्हणजे स्लिपिंग नाही आहे याच्यामध्ये, आणि याच्यामध्ये स्लिपिंग आहे, रोलिंग नाही आहे. ओके, याच्यामध्ये फक्त स्लिप होत, याच्यामध्ये फक्त स्लिपिंग चालू आहे. सो एक्सेलरेशन जी साइन थीटा. हियर वी विल राइट जी साइन थीटा. सो व्हाट वी वेर आस्क्ड, सर वी वेर आस्क्ड रोलिंग विदाउट स्लिपिंग, एक्सेलरेशन ऑफ रोलिंग विदाउट स्लिपिंग डिवाइडेड बाय एक्सेलरेशन ऑफ स्लिपिंग विदाउट रोलिंग. सो लेट अस राइट इट डाउन अगेन. सो एक्सेलरेशन ऑफ रोलिंग without slipping, and here acceleration when there is slipping without rolling. This ratio we are asked, what are the formulae? Sir, the formulae are here, rolling without slipping we have formula g sin theta upon 1 plus k square upon r square, and acceleration without rolling we have formula simply g sin theta. Sir, g sin theta gets cancelled. What we have in the numerator? Sir, in the numerator we have 1 upon 1 plus k square upon r square. Don't do this r square here, so r square upon r square plus k square, don't do this, don't do that, because k square upon r square can be written directly. Now what is k square upon r square? We have discussed multiple times. What is k square upon r square? So it is coefficient of mr square. How to find coefficient of mr square? By writing moment of inertia. What is this object? It is sphere. About which axis it is rotating? About diameter. See the point which is coming out of the plane. About diameter, what is the moment of inertia? It is 2 by 5 mr square. It is 2 by 5 mr square. Okay. So what is the coefficient of mr square? It is 2 by 5. So what is k square upon r square? It is coefficient of mr square. What is k square upon r square? It is coefficient of mr square. So it is simply 2 by 5. So here you will write 1 divided by 1 plus k square upon r square, means here 1 divided by 1 plus k square upon r square is 2 by 5, coefficient of mr square. What is coefficient of mr square? It is 2 by 5. Fine. So here now you can do this phi in the this phi here, or let us write it. 5 plus 2 is 7 upon 5, and this phi goes in the numerator, so answer becomes 7 upon 5. Now without calculation, first observe what are the options. Question number 9, 5 is to 7, 7 is to 5. Which is the correct option? 5:7. 5:7. Okay, is this question clear to all of you? Reply me in the chat box. दोन acceleration बाळांनो विचारले होते. एक होतं g sin theta into bracket 1 plus k square upon r square आणि दुसरं होतं g sin theta. एक होतं रोलिंग वालं, एक होतं स्लीपिंग वालं. ऍक्सलरेशनचा रेशो विचारला होता. समजायला लागलेत का एक्झाम्स मध्ये क्वेश्चन कसे येणार आहेत? तुम्हाला पाठ असणाऱ्या फॉर्म्युल्यामधूनच क्वेश्चन्स येतात, काही वेगळं नसतं. फक्त जरा प्रॅक्टिस लागते. Is that clear? Reply me in the chat box. Is this question clear to all of you? Shall we move on to the next question? Yes, good. Reply me clear and written so that we can move on to the next question. माझ्यावर लिहित पण चला, एकदा रफ कॅल्क्युलेशन होऊन जाऊ दे. किती वेळ आहे आपल्याकडं? We have some 10 or 15 minutes now. Fine. We will solve the next question. That is question number 15 now. Okay. Question number 15. See what is given in the question number 15. Let us read the question number 15. Try to solve the question also. Three bodies, ring, solid cylinder and the solid sphere roll down the same inclined plane without slipping. So this is rolling without slipping, pure rolling motion. So there are three objects. All are capable of rolling on the same incline theta. Angle of inclination theta is same for all. First object is what? First object is ring. Second object is solid cylinder. And third object is solid sphere. Solid sphere. Okay, sir, fine. The radii of bodies are identical. सगळ्यांच्या radius equal आहेत. So radius of all are equal. Okay, given data extract. Which of the bodies reach the ground with maximum velocity? Velocity at the bottom maximum कोणाची असेल? Ring, solid cylinder or solid sphere? Okay. So velocity max for which body? Okay, this is called as modeling the question. This is what is given, this is what is asked, this is the diagram. So velocity maximum कुठल्या बॉडी साठी असेल? Fine. Velocity at the bottom, or which body will reach the, what we shall write? Velocity at bottom will be maximum for which body? असा क्वेश्चन पाहिजे. Velocity at bottom will be maximum for which body? So आपण काय करायचं? Velocity at bottom चा फॉर्म्युला लिहायचा. What is the formula for velocity at bottom? Sir, under root 2gh into bracket 1 plus k square upon r square. Under root 2gh into bracket 1 plus k square upon r square. Fine. So here, see, h for all the bodies, h will be same. G is universally same. Sorry, not universally. I shall say for all bodies it is same. Okay. 9.8 it is same. H is same. 2 is same. Now, can you observe? Velocity will be maximum if this entire bracket is maximum. If this entire bracket maximum, out of which 1 is the fixed quantity. So if k square upon r square is maximum, ज्याचा k square upon r square जास्त असेल त्याची velocity at the bottom जास्त असेल. So काय करायचं? k square upon r square च्या व्हॅल्यूज लिहायच्या. ओके, k square upon r square. k square upon r square for ring किती असेल? For ring, what is moment of inertia? About this axis, what is moment of inertia of the ring? About an axis passing through center and perpendicular to the plane. It is simply mr square. म्हणजे 1 times mr square. What is the coefficient of mr square? It is 1. So k square upon r square ring साठी 1 येणार. Now solid cylinder, k square upon r square for solid cylinder. Solid cylinder म्हणजे काय? Ultimately डिस्कच असणार आहे. डिस्क over disk. So what is its moment of inertia about an axis passing through center and perpendicular to the plane of the disk or the cylinder? It is 1/2 mr square. 1/2 mr square. 1/2 is the coefficient of mr square, and k square upon r square means coefficient, which is 1/2. Here 0.5. Third is what? Third is, sir, solid sphere. Third is solid sphere. Now solid sphere, while rolling down the plane, it will roll along its diameter. Sorry, it will roll on the ground, but it will rotate along its diameter, about its diameter. What is the moment of inertia of the sphere about diameter? Sir, it is 2/5 mr square. So what is k square upon r square for solid sphere? Sir, it is 2 by 5 mr square. So 2 by 5 will be the ratio. What is 2 by 5? So it is 0.4. So which is the highest value? So ring is the highest value. 1 is more than the 0.5 than the 0.4. So 1 is the highest. So त्याचा k square upon r square highest. Ringचा k square upon r square highest आहे. तर त्याचाच 1 plus k square upon r square highest असेल. त्याचीच अंडर रूट ची व्हॅल्यू हायेस्ट असेल. त्याचीच velocity at the bottom highest असेल. So which object will reach the bottom first? Sorry. Which object will have maximum velocity at the bottom? Ring will have maximum velocity at the bottom. Are you getting this? Ring will have max velocity at bottom. Are you getting this? Reply me in the chat box. Is this type of question? Okay, here we need somewhat thinking as well. Okay, thinking and comparison as well. बघा मी क्वेश्चन दाखवते परत एकदा सगळा. समजला का तुम्हाला? Tell me, is this question clear to all of you? Good. So question number 15 we solved. The answer is ring will be having maximum velocity at the bottom. समजा लागले का बघा. Okay. So now few questions are still remaining. I think in this lecture these many questions are enough. Okay. Remaining two and three questions are remaining that we will do in the next lecture, and along with that we will start the new chapter also. For that also we will solve the fundamental questions, then advanced questions, and then the previous year questions. Okay. Will that be okay if we continue with this? Previous year पण बघायचं, मिसलेनियस वाले एक्सरसाइज 2 मधले पण बघायचे, एक्सरसाइज 1 मधले पण क्वेश्चन्स बघायचे. म्हणजे सोपा आला तो सुद्धा सॉल्व्ह होईल, मीडियम डिफिकल्टीचा आला तो सुद्धा सॉल्व्ह होईल, आणि एक्झामचे तर आपण सॉल्व्ह करायचे आहेतच. म्हणजे डिफिकल्ट वाले सुद्धा जे काय असतील ते सुद्धा सॉल्व्ह होतीलच. Okay, will that be okay? Just reply me last time. Will that be okay if we continue with this method? Exercise 1 मधले क्वेश्चन्स, 2 मधले क्वेश्चन, प्रीवियस इयर, एक एक चॅप्टर घेऊन आता जेवढे चॅप्टर आपल्याला करता येतील ना तेवढे आपण करत राहायचे टिल द एक्झाम. कंटिन्यू ठेवायचं. ओके, म्हणजे एका साइडनं माझं पण सॉल्विंग असेल, एका साइडनं तुम्ही सुद्धा सॉल्विंग करत राहाल. फाइन. सो इन दिस लेक्चर लेट मी एंड दिस लेक्चर. इन दिस लेक्चर we will stop at this point. Let me end this lecture at this point. Okay, chalo, bye bye everyone. Let me end this lecture.